minimum amount of energy required to remove the loosely held electron when isolated gaseous atom or ion. So this is the definition of the ionization energy. The minimum amount of energy required to remove the loosely held electron of an isolated gaseous atom or ion. That is called ionization energy. It means what? So we know that when you are telling it's a metal, when they will lose the electron, so that time they will attain the positive, they will gain the positive charge, is it? So to remove that electron, some amount of energy is required. That energy is called ionization energy. So very simple. So metals they are going to lose their electron. By losing their electron, they will attain the positive charge, is it? To lose their electron, so we have to remove that one. So it means we have to escape from that electron from the outermost shell. So to that, minimum amount of energy is required. Then they will attain the positive charge. So that energy is called ionization energy. Okay, ionization energy. The ionization energy depends on two factors. So it depends on two factors. One is, as in the last property, atomic size, and next one nuclear charge. Atomic size and nuclear charge. So atomic size. So what will happen to the ionization energy? It is required more energy or less energy. So in case of as the atomic size increases, then why atomic size increases? Because addition of new shells, is it? Then minimum amount of energy is required, because as the atomic size increases, nuclear pool getting decreases. So because of that reason, as the atomic size increases, minimum amount of energy is required to remove the electron from its outermost shell, or which is loosely held electron from its outermost shell. Okay. So as the atomic size increases, minimum amount of energy is required, because nuclear charge will decreases. Atomic size increases means nuclear charge will get decreases. So because of that reason, minimum amount of energy is required. Clear? And nuclear charge. If nuclear charge is more, then what? Then minimum or maximum amount of energy is required. So if nuclear charge is more means, so at that time atomic size it will get decreases. Is it? Atomic size it will get decreased. So nuclear charge more means the nucleus present in the center, it will attract the electron towards itself. And atomic size is also very small. So that time large amount of energy is required to remove the electron from its outermost shell. So large amount of required if nuclear charge is more. Okay. So that is regarding about the atomic size and nuclear charge. Now moving to the across a period, what will happen to the ionization energy? So if you move across a period, we already know that its atomic size will get decreases. So if you move across a period from left to right on the periodic table, we know that atomic size will get decreases. Then so minimum amount of energy is required. It means ionization getting increases. For example, I told that elements in the second period. Now I am talking across a period. Okay. Across a period. So across second period elements. So here lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So neon we will not consider because it is an inert gases. Clear? It is an inert gas. And now I am considering the second group elements. Decreases means their size will get decreases, condense. That time more amount of energy is required. More amount of energy is required to remove the electron from its outermost shell. To remove the electron from its outermost shell. So, for example, look at it. So, second period elements across the period. Ionization energy. How it is increases? Let's see then. Sodium, second, lithium, beryllium, boron, carbon. Lithium, beryllium, boron, carbon, nitrogen, oxygen. One more is there. That is fluorine. Okay, neon water. Now, what will happen to the ionization energy? The first one, lithium, 520, 899. This is expression. 801, 1086, 2402, 1681. 1681. Now look at that. Across a period, the ionization, this is the expression, yes? Okay, don't consider this one. So across a period, ionization energy increases. Looking the values, you can tell that 520, that is the ionization energy of lithium, and 899, that is the ionization energy of beryllium, and ionization energy of boron 801, 801, and carbon 1086. So it means across a period, ionization energy increases. Across a period, ionization energy will get increases. Understood? I hope that you understand this one. By looking the values only we can tell that. And one more thing, to measure. So to measure the ionization energy, unit is there. That is electron volt per atom. Electron volt per atom. Unit. Unit to measure the ionization energy. Electron volt per atom. Electron volt. You can write this is the unit to measure the ionization energy. And SI unit is kilojoule per mole inverse. SI unit. Kilojoule per mole. Kilojoule mole inverse. That also can write there. Kilojoule mole. Kilojoule per mole or kilojoule mole inverse. Okay. So these are the SI unit and unit. Electron volt per atom. Okay. So across the period, so the third period, fourth period, or fifth period, ionization energy will be increases. Okay. What about the period? And next, down the group. Down the group, what will happen to the ionization energy? What will happen to the ionization energy? So down the group, we know that already as we move down the group, top to bottom. So atomic size increases. Atomic size increases. It means nuclear charge getting decreases. So it's when compared to the atomic size, so nuclear charge is less. The energy is less. Nuclear charge is less compared to the atomic size. That time, what minimum amount of energy is required. So not large amount of energy, minimum amount of energy. Because atomic size is more now. Atomic size more means number of shells more. So nuclear charge little less compared to the atomic size. That time the electrons attracted towards the nucleus is little less. Clear? Because atomic size is more. So shells are far away from the nucleus. Shells are far away from the nucleus. Clear? So because of that reason, so ionization energy it will getting decreases. So because of that reason, ionization energy getting decreases because of the increase in the atomic size. So ionization ionization energy, it will decrease as we move down the group. So let's see that. Energy down the group. Ionization energy down the group. So first group elements: lithium, sodium, potassium. Lithium, sodium, potassium. Then rubidium, cesium, francium, Z. So this is the first group elements. Here, ionization energy. This is the first group. Ionization energy, first group. Cesium, I am starting cesium. This francium is the number. Lithium, 520 electron volt per weight. 496, 490, 403, 374, 374. Now look at the ionization energy. As we move down the group, it will decreases. So as we move down the group, ionization energy decreases. What is the reason? Because atomic size increases. Atomic size increases. That is only reason. Okay. And nuclear pool getting decreases. Nuclear pool getting decreases because shells as moves far away from the nucleus. Shells moves far away from the nucleus. That is the reason. Clear? It gains the positive charge. So it is a metal, is it? So metal only they will gain the positive charge. So for example, M, that is in gaseous state, plus ionization energy. Electron minus. Now look at that. So that should be the gaseous state. M may be any element. That should be the gaseous state. If you provide the ionization energy, you get the positive metal, positive element. Positive element, that is metal. Positive element, that is a metal, and it will release the ion. It will release the ion. It means positive metal or positive element. Okay. So this is about the ionization energy. Next, I will move to the next periodic property, that is electron affinity. Electron. The last periodic property, what you learned, to remove the electron from its outermost shell, we need some amount of energy. Is it? So after losing the electron, they will become metal. Whereas in case of non-metal, they will gain the electrons. They will gain the electrons. That time also, some amount of energy is released while adding the electron. While adding the electron to their outermost shell, some amount of energy will be released. That is called electron affinity. That is the electron affinity. So definition what? The amount of energy released while converting a gaseous neutral atom into a negatively charged particle. Negatively charged gaseous ion while adding the electron. The minimum amount of energy is released. The minimum amount of energy released by converting neutral gaseous atom into a gaseous negatively charged particle. Negatively charged particle. Gaseous ion, that is generated. Negative ion, that is negatively charged particle by adding an electron. By adding an electron. So vice versa of ionization potential. Ionization potential. Whereas in case of ionization potential, what will be there? So to remove the electron, some minimum amount of energy is required. Here that time energy is required, but to add the electron, energy is released. To add the electron, that time minimum amount of energy is released. So that is called electron affinity. The minimum. So to become a non-metal means we will add the electron. I said they will accept the electron, gaining electrons, gaining the electron. That time energy will be released. That is called electron affinity. The general form of that one, X may be any element that is in gaseous state. So we will add the electron. That will becomes the X minus plus electron affinity. Electron affinity. So this is also in gaseous state. This is also in gaseous state. Clear? So our electron affinity nothing but the minimum amount of energy released by converting a gaseous atom into a gaseous ion by adding the electron to the outermost shell. Clear? So this is the general representation of the electron affinity. So X may be any element. For that we will add the electron. We will gain negative charge X minus plus electron affinity. Clear? Next, so electron affinity depends on two factors. The first one is the atomic size and second one is the nuclear charge. So depends on two factors. One is the atomic size and second one is the nuclear charge. First one is the atomic size and second one is the nuclear charge. So smaller the atomic size, greater will be the electron affinity. So as the atomic size decreases, then electron affinity will be more. So as the atomic size decreases, atomic size is smaller, then electron affinity will be more. Atomic size smaller means the nuclear charge is more. Electrons will attracted towards the nucleus. So smaller the atomic size, then more will be the electron affinity. Clear? And next, nuclear charge. So nuclear charge, greater the nuclear charge, then automatically this electron affinity will be more. So greater the nuclear charge. So greater nuclear charge means automatically atomic size will be less. Size will decreases. So small size will be there. Electrons are attracted towards the nucleus. So that time greater nuclear charge and greater will be the electron affinity. So what will happen to across a period? What will happen to the electron affinity across a period? Atomic size decreases, then there will be increase in the electron affinity. as we move across the period, electron affinity increases. Electron affinity increases because atomic size getting decreases. Now look at the values now here. So if you have a textbook, you can see that. So that one I have written on the board. So minus hydrogen electron affinity minus 73. Now look at that. So moving from left to right. So 48. Now look at that. Lithium, neglect the side there. Neglect the side. Okay. So lithium electron affinity 60, whereas fluorine 328. And look at that. 60, 88, 112. How it is increases? 141, 328. So it is increases from left to right of the periodic table across a period. Now look at that. The last third period, sodium 53, aluminum 50, silicon 119, and this is the expression gas, and sulfur 200, and chlorine 349. So from these values we can conclude that across a period, it means if you move from left to right of the periodic table, electron affinity will be increases. Now move to the next. Down the group, what will happen to the electron affinity? So we already know that as we move down the group, atomic size getting increases. So because of that reason, electron affinity will be getting decreases. So down, this is increases. Across the period, it will increases. Now down the group. Down the group. Minus 73, minus 60, 53, 48, 47. Now look at their values. Look at the values here. So as we move down the group, hydrogen 73, next lithium 60, sodium 53, potassium 48, rubidium 47. By looking at the values, you can tell that as we move down the group, electron affinity, it will decreases. Electron affinity will be decreases as we move down the group because atomic size increases than the nuclear charge. So there is an increase in nuclear charge, but compared to the atomic size is more than the nuclear charge. So because of that reason, electron affinity will decrease us down the group. Then I will move to the next electronegativity. Next characteristics. The next periodic property is electronegativity. It means what? Electronegativity, the tendency of an atom in a molecule to attract the shared pair of electron. The tendency of an atom in a molecule attracts the shared pair of electrons. It means what? Example, so we know that methane. So what is the molecular formula? Methane CH4. How to write? So it is which type of bond? Sharing. It is a covalent bond. So CH4 is a covalent bond. How it is shared this electron with hydrogen? How carbon is sharing electron, hydrogen? So the capacity. So carbon has the capacity to attract the electrons of hydrogen towards itself. Then only it will form the compound methane. Now look at that. How they are sharing the electrons. So carbon valency 4. So hydrogen here valency 1. 4 atoms of hydrogen is there. Carbon valency 4. So it means valency 4 means 4 electrons in their outermost shell. And hydrogen valency 1. Now look at it. Write it. So 4 valence electrons in the carbon. 1, 2, 3, 3, 4. Okay. Next, hydrogen. Hydrogen 1. Or you can write inside here only. Okay. So dot is the valence of carbon and into what is there now? That is the valence of the hydrogen. Now see that. So it attracts the electron towards itself. So it will so what is the definition of electronegativity? Electronegativity, the tendency of an atom in a molecule to attract the shared pair of electrons. So carbon, by sharing the electrons with the hydrogen, it will form the compound methane. That is the capacity, tendency of the carbon. Tendency of the carbon. That is the electronegativity. The tendency, electronegativity depends on two factors. So same as it is we learned the previous properties. One is the atomic size, another one is the nuclear charge. Another one is the nuclear charge. Atomic size or size of the atom. Atomic size. Second one is the nuclear charge. Atomic size and nuclear charge. So if atomic size is more, then what will happen to the electronegativity? So if atomic size is more, this electronegativity will be decreases. So lesser will be the electronegativity. Atomic size is more means, so lesser will be the electronegativity. And similarly, if greater the nuclear charge, that time more will be the electronegativity. So atomic size is more, electronegativity will be lesser. Clear? Nuclear charge is more, then electronegativity will be more. Electronegativity more means number of shells will be decreases and the nuclear pull will be increases. Nuclear pull will be increases. That time the electronegativity will be increases. Electronegativity across the period. Size decreases. Atomic size decreases. Then what will happen to the electronegativity? It will be more. It will be more. Then more will be the electronegativity. Atomic size decreases. Then more will be the electronegativity across the period. Across the period, decrease in atomic size. Decrease in atomic size. Then increase in electronegativity. Electronegativity. So, if atomic size decreases, then electronegativity increases. So, across the period, atomic size will decreases, then there will be increase in the electronegativity. Clear? And next, down the group. So, down the group, we already know that. So, atomic size will be more. As we move down the group, atomic size will be more. So, as I told, in these different factors, atomic size is more, then electronegativity will be less. Because of the increase of the atomic number, then so what will happen to the electronegativity? So down the group it will decreases because of the increase in the atomic size. So down the group there will be increase in the atomic size, but decrease in the electronegativity. So the electronegativity value will be goes on decreases down the group. Clear?